Good morning, students. Chapter 2, Equipotential, Surfaces, Potential Energy, Capacitor. Each and every topic is over. Most of illustrations are completed. Exercise is also over. Okay. Yes, remaining questions we will see. See, it is one question. Exercise 2.17. Exercise 2.17. What you are given? You are given a cylinder of linear charge density lambda surrounded by coaxially hollow cylinder, like this. Okay, so again you are given one cylinder of linear charge density lambda surrounded by coaxially hollow cylinder. Your question is, you have to find what is electric field in region between two cylinders. What is electric field in region between two cylinders? Okay, you have to find electric field in this region. To find electric field, we will use Gauss law. See, to find electric field in this region, I am taking one Gaussian surface, also one cylinder of radius r. Okay, so here I have one Gaussian surface, here I have one Gaussian surface, okay, of radius. See, inner radius of cylinder is A, outer radius is B. Okay, it is Gaussian surface. This is Gaussian surface having radius r. Okay, so now we will apply Gauss law. See, what is Gauss law? Here, flux phi is equal to integration E dot ds is equal to sigma q upon epsilon 0. Integration E dot ds is equal to sigma q upon epsilon 0. Okay, as we have to find electric field in this region, I am assuming, see, they are conductors. So let, due to charge is given on this inner cylinder, outer cylinder is also conductor, so charge is induced on it. So I am assuming let charge density on outer cylinder is positive and charge density on this inner cylinder is negative. Here it is positive and here it is negative. Okay, so what is direction of electric field? Direction of electric field is in this direction. Clear about this? Okay. We know that area vector is always perpendicular outside. So for this Gaussian surface, if I am taking area vector, it is always perpendicular outside. Clear about this? Okay. So how to write this equation? It is integration T ds cos 180. It is integration E ds cos 180. Any doubt? Okay. Is equal to sigma q. Sigma q means charge enclosed by Gaussian surface. Gaussian surface is this cylinder of radius r. And we know that this inner cylinder, of radius a is inside this Gaussian surface. Okay. So total charge on this cylinder is enclosed by this Gaussian surface. Now what is linear charge density of this cylinder? It is minus lambda. What is its length? It is lambda. So what is charge enclosed? Yes, it is minus lambda into L upon epsilon 0. Clear about this? Okay, now E, that is electric field, constant, so it is out of integration. Okay, cos 180 means it is minus, and here it is integration ds is equal to minus lambda L epsilon 0. Now integration ds means surface area of this Gaussian surface. E, it is one cylinder of radius r and length L. Then what is its surface area? Yes, its surface area is minus E. Surface area is 2 pi Rl is equal to minus lambda L upon epsilon 0. Minus cut. Okay, L is also cut, and if you make E as subject, then E is equal to this lambda upon 2 pi epsilon 0. 1 upon R. So it is equation of electric field. Okay. How to find? Again, inner cylinder, outer cylinder, inner cylinder radius A, outer cylinder radius B. Linear charge density is given to lambda. So I am assuming that if charge density of outer cylinder is plus lambda and of inner cylinder is minus lambda due to charge induction, assume 1000 surface of radius R, okay, where R is greater than A and less than B, means between them, okay. Apply Gauss law, integration E dot ds is equal to sigma q upon epsilon 0, electric field in this direction, theta vector from this outside, so angle between them is 180 degree, cos 180 minus 1 E integration ds minus lambda L upon epsilon 0. Why minus lambda L? Because we have assumed the charge on this cylinder is minus lambda L, on this is plus lambda L. Okay, so it is minus lambda L, make E a subject and E is equal to lambda upon 2 pi epsilon 0 1 upon R. Clear about this? Clear about this? Okay. Now, yes, electric field we have found. Now, one more thing we will find, that is capacitance. Now, how to find capacitance? Capacitance C is equal to Q upon V. What is the equation of capacitance? C is equal to Q upon V. So, first of all, we have to find potential difference. How to find potential difference? See, in the last lecture we have studied. See, this arrangement is nothing but cylindrical capacitor. This arrangement is nothing but cylindrical capacitor. In the last lecture we have studied about spherical capacitor. Spherical capacitor. It is nothing but cylindrical capacitor. See, because two conductors are filled with air as medium. With air as medium. Okay, so it is nothing but one capacitor. So how to find capacitance? First of all, we will find potential difference between this inner cylinder and outer cylinder. First of all, we will find potential difference for inner cylinder and outer cylinder. See, potential difference. How to find potential difference? V is equal to, we know its equation, minus A to B E dot dr. In the last lecture, for spherical capacitor, we got this equation, V is equal to minus R1 to R2 E dot dr, if you remember in last lecture. Okay, so it is similar equation. V is equal to minus A to B E dot dr. Okay, now is equal to minus A to B E dr cos. What is angle between electric field and displacement? Electric field, see, it is in this direction, and potential difference from A to B means we are moving A to B in this direction. So yes, again they both are in opposite direction. So what is angle between them? It is cos 180. And we know that what is value of cos 180? Cos 180 is minus 1. So this minus 1 and this minus 1 cuts. So V is equal to it is integration A to B E dr. Okay. Now what is value of electric field? We know E is equal to lambda upon 2 pi epsilon 0 1 upon R. So V is equal to integration A to B lambda upon 2 pi epsilon 0 R dr. Lambda constant, 2 constant, pi constant, epsilon 0 constant. So if we take them common, that means lambda upon 2 pi epsilon 0 common, integration A to B 1 upon R, integration 1 upon R dr. Okay, now you know what is integration of 1 upon R with respect to R. It is log R. Okay, so is equal to lambda upon 2 pi epsilon 0. Lambda upon 2 pi epsilon 0. It is ln R and limit is from A to B. So you can write this as lambda upon 2 pi epsilon 0 ln B minus ln A. Or you can write lambda upon 2 pi epsilon 0 ln B divided by A. It is equation of potential difference. You have to find what is capacitance. Then how to find capacitance? C is okay. Now capacitance C is equal to, it is Q upon V. What is Q? What is Q? Charge on plates of capacitor. Means charge on inner cylinder or charge on outer cylinder. It is lambda L divided by, what is equation of V? It is lambda upon 2 pi epsilon 0, means 2 pi epsilon 0 in numerator, and lambda ln B upon A, ln B upon A. So lambda cut. So what is equation of C? C is equal to 2 pi epsilon 0 L upon ln B upon A, and it is your equation of capacitance. Okay. See, now one additional topic, capacitance of a sphere. A sphere, you know what is definition of capacitor? Capacitor means two conductors separated by insulating medium. So how can we say capacitance of a sphere? Yes, in this case we have to consider another sphere at infinite distance. At infinite distance. So it is one sphere. Another sphere is at infinite distance. Another sphere is at infinite distance. Then this sphere behaves as a capacitor. This sphere behaves as a capacitor. How to find its capacitance? See, if charge on sphere is Q, radius is R, then potential V is equal to Q upon R. C is equal to Q upon V. So if you make C is equal to Q upon P, it is R upon K. K is 1 upon 4 pi epsilon 0. So C is equal to 4 pi epsilon 0. R is equal to R by K. Is equal to R by K. Okay. You have to remember this equation. Okay. For a single sphere of radius R, what is capacitance? Capacitance is equal to 4 pi epsilon 0. R is equal to R by. Okay. Now, in the last lecture, we have obtained one equation for spherical capacitor. In this lecture, we have obtained one equation for cylindrical capacitor. Okay. Now some questions based on it. See, exercise 2.20. One spherical capacitor is given, having inner radius 12 cm, outer radius 13 cm. Outer sphere is earth and inner sphere is given charge 2.5 microcoulomb. And space between them is filled with dielectric. K is equal to 32. Okay. What is capacitance? See, in last lecture we have obtained one equation. C is equal to 4 pi epsilon 0 R1 R2 upon R2 minus R1. If you know this equation. Okay. In last lecture we have derived. Epsilon 0 is used when medium between them is air. When medium between them is air. Here medium between two sphere is dielectric, having dielectric constant 32. So you have to replace this epsilon 0 by epsilon. Clear? And how to write this now? It is 4 pi epsilon 0 epsilon r. So you can write it is K R1 R2 upon R2 minus R1. Clear? Yes. Okay. Potential of inner sphere. How to find potential? V is equal to Q upon C. Q is given C. You will find from first question. Okay. Question C. Compare with capacitance of a sphere of radius 12 cm. You have to compare this capacitance with a capacitance of a sphere of radius R. Sphere of radius R. R is equal to 12 centimeter, means 0.12 meter. So what is its capacitance? See this. It is 4 pi epsilon 0 R. It is 4 pi epsilon 0 R. Okay. You will get this answer. You will get this answer. Then you have to compare these two answers. You have to compare these two answers. Okay. And write your answer. Now last question is based on cylindrical capacitor. Length of cylindrical capacitor is 15 meter, inner radius 1.4 centimeter, outer radius 1.5 centimeter, outer cylinder is earth, inner cylinder is given charge Q is equal to 3.5 microcoulomb. Find what is capacitance and find what is potential of inner cylinder. See what is equation? C is equal to 2 pi epsilon 0 L upon Ln V upon A. Okay, now you can easily find what is value of this. Also, V is equal to Q upon C. V is equal to Q upon C. Clear? So, in last two lectures, what we have studied? In last lecture, we have studied about spherical capacitor. And in this lecture, we have studied about cylindrical capacitors. Yes, you have to remember their equations. Pause your video and write down from board.